Okay, this is just a very short video on significant figures. So what we first just want to understand is anytime we take a measurement is only as good as the instrument we're using. So the beaker I'm holding here has graduations of 50, 100, 150, 200, 250, 300. Basically, graduations are every 50 milliliters. So if it were slightly above, say, the 300, we could make an estimate, but we could make it no better than, if this is 100 milliliters, every 100 milliliters, we can only make it 2 every 10 milliliters. So if it was slightly above, maybe I'd call it 310, 320, something like that. But there would be some variation. I'll put this here. So let's say it was 320 milliliters, and oftentimes we'd write plus or minus, we might say 10 milliliters. But the point is, there was some uncertainty there in the tens place. We knew for sure, if it was a little above 300, that it'd say more than 300, less than 400. But now we can't say it's exactly, say, 323.56 milliliters, because our scale wasn't that good. So this is where the notion of sig figs comes from. So the concept of sig figs is due to what we call uncertainty in every measurement. So we say, what are sig figs? Well, they're all the digits that we know for certain from a measurement, plus one more we estimate. All right. So what we need to remind you of now is when we see a measurement, that measurement is going to be communicating something to the reader about what kind of instrument was used. One more time, if I use this one has graduations. Here's 10, 15, and then you can see there's 16, 17, 18, 19, 20. So if I have graduations that are every milliliter, I can read the scale. If there was something, say, between, let's say, 16 and 17 here, maybe it was right in the middle, then we'd call it 16.5 milliliters. So in that situation, the scale was good to the ones, and then I estimate one more place to the tenths. So what this tells us is, when I look at this number here, there's where the uncertainty lies, in the tenths, hundredths place, and the scale would have been good, one decimal place to the left, to the tenths. This one would have been estimated here at the hundreds place, so the scale must have been one decimal place to the left, the thousands place. Alright, now quick review here. If I just kind of make a quick sketch of the US here. Here's my Pacific side, here's my Atlantic side. We just use this as an illustration to highlight P. When a decimal is present, we start on the left-hand side. When decimal is absent, we start on the right-hand side, Atlantic side. So I ask myself, is a decimal present here in 0.0460? And for sure there is. So I start on the Pacific left-hand side, but I don't start counting until I hit a non-zero. That just means 1, 2, 3, 4, 5, 6, 7, 8, or 9. So I don't count it, but now I count everything afterwards. So I go, yes, yes, yes. This will have 3 sig figs. The uncertainty is in my last sig fig here. So that's the tenths, hundredths, thousandths, 10,000ths place. So my scale must have been good to the tenths, hundredths, thousandths. When I look at this number here, I ask myself, is a decimal present? And there is. So again, I'm going to start on the left-hand side. So I go 1, 2, 3, 4, 5. I have 5 sig figs. My last sig fig to the right is where the uncertainty lies. Here, so that's tenths, hundredths, thousandths. And then my scale must have been good to the hundredths in that particular measurement. Let's do another one here. Number 11, there is no decimal present. There's nothing there, so I'm going to start on the Atlantic side. But again, I don't count it until I get to a non-zero, so no, no, yes, yes. So we'll have 2 sig figs. The uncertainty here is at the 1, so that's the ones, tens, hundreds. And the scale must have been to the thousands. If I flip it over, and we do some of these. Number 18, decimal is present. No, no, yes, yes, yes. So I'm going to have 3 sig figs. All right, in some of these, this column here, I'm going to ask you to put it in scientific notation. So I'm going to put as many digits in scientific notation as there are sig figs. So I have 3 sig figs, so I write those 3 sig figs. I go 6, 8, 0. And I put a decimal between the first and the second sig fig. Now, even though this is 0.06, I'm moving the decimal over between the first and second sig fig. Then I'm going to say times 10, and because I moved it 1, 2 places over to the right, this means it's times 10 to the negative 2 power. Let's do this one here, number 24, 330, but there's no decimal present. So I start on the Pacific side, start here, and I count. I'm sorry, I messed that up. I start on the Atlantic side, the right side here, and I go no, yes, yes. So I'm going to have 2 sig figs. So I put those 2 sig figs, I go 3, 3. I put a decimal in between them, and then the decimal is understood to be here, and I'm going to move it 1, 2 places over to the left, so that means this is times 10 to the second power. Alright, let's do one more here. 33. A decimal is present, so we start on the Pacific side, but only count starting with first non-zero. So 0 doesn't count, then we go yes, 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 yes. 4 sig figs. I write all those 4 sig figs, so I'm going to write 3, 6, 0, 0. I put the decimal between the first and second, right there. And then I would have had to move the decimal 1 place to get it there. So I say times 10, and since I moved it to the right, 10 to the negative first power. Just a quick review here on 41. You can see that would be 3 sig figs. On 38, no, no, yes, yes, yes. So this is going to be 3 sig figs. Okay, hope that helps.